Hello everyone. So in this lecture we are going to talk about inserting a new node in the linked list. So far we have uh, got the foundation of the linked list, that what is linked list, how it looks like, and what is the overall logic of linked list. Now we will discuss about its operation, that how these operations will be performed. When we say inserting is possible, as we have discussed. It will be inserted at the beginning or at the last or somewhere in the mid position. So we will have a look that what is the logic and then how we can write the algorithm. Okay, so let's start. Okay, so inserting a new node. Here we are interested to insert a new node in our linked list. Now, to perform this operation, we need to have understand the entire scenarios. We may have different cases, and also there are certain scenarios that we need to understand. So one is inserting into an empty list. So if you're inserting a node and there is no node already existing, that means there is no linked list existing. That means you are inserting this node as a first node. So this is the case, inserting into an empty list, or already the linked list is existing and you are interested to insert at the beginning, at the front. This is already the linked list is existing and you want to insert at the back, and this is somewhere in anywhere in the middle position. When I say middle, it's not exactly the mid position, but it is somewhere in between the first and last. So though we have uh, we can see here four cases, or the four scenarios, but actually there are two cases. So we can combine these situations into two cases as a whole. So inserting as a first node, case 1 and case 2 will be dealing with the same kind of logic, though the scenarios looks like a different, but the logic that we are going to use, it will be applicable the same as in this one and the two. Inserting in the middle and at the last will again, though these scenarios are different, but the logic that we will use to implement these scenarios will be actually treated in the same way. So this 3 and 4 will be used as the same logic. This first and second will be using the same logic. We'll see how. So insertion at the start. So inserting a new node is actually a simple task. It will just require two steps to perform. Now, before we start understanding the logic, let us understand some more things. New node should be connected to the first node, which means that the head. So if you are interested to add a new node as the first node, that means you want to make this node as the starting node. And if you want to make this node as a starting node, that means the head or the front pointer must now point to this node. This is the thing actually when you insert at the beginning. New node should be considered as head. It can be achieved by declaring the head equals to the new node. So if you already have a linked list, this is your linked list. This is the last node, this is the first node. Head points to this first node. And if you have a new node, we are calling as a new node. And if you want to insert this node as a beginning, that means it actually means that you want to make this node to be pointed by header, means head should point to this node, then this node will become the head node. Okay, but to make it possible we need to do more steps, because head is pointing to this. Now head need to point to this node, and also this node should point to this node, so that this earlier first node now can be treated as a second node. That means also that this address need to be kept here at this address field. That's why this is now I'm going to point to this node. Okay, so this is the logic that is need to be implemented. So let us see the algorithm, that how all these things can be achieved. So before we actually move to the algorithm and to the actual program stuff, we need to understand logically that what actually we are looking for. Unless you understand the scenario, you are not in a position to understand the algorithm. Okay, let us understand the logic that how the things work. This is our new node which we are interested to insert, and this is the linked list which we are having. It consists of three nodes, 1, 2 and 3, and the first node is pointed to by the front, means front keeps the address of the first node. Now make the new node point to the first node. So what actually we are looking for, if we want this node to act as a first node, that means the previous first node must become the second node. So this node must point to this node. Now how this is possible? So when you created a new node, uh, its address is given to the node. This is a pointer variable, you can say, and this actually holds the address of this new node. But this node is not connecting to any other node. This is a isolated node. If you want to connect this node to this node, so what is required? So actually we can make it in two parts. Okay, this is your data part as we have discussed, and this is your link part. Link part is the address part. So data part is a area where we store our actual data, the value which we are looking for to store. Now what we will do, whatever the address is written here, now this is a pointer that keeps the address of the first node. Now if I write this address here, that means that this will now link to this node. Okay with this? So whatever the value is written here, you just copy this value at this location. It actually means that now you are able to point from here to this. So now we are able to connect the first node and make it as a second node. But still one thing is remaining. Still this is not pointed to by the head must point to this, means the front must point to this. So sometimes I am calling head and front, both are having the same meaning. Okay, so head must point to this. So how the head will get the address of this node? The address of this node is actually stored at node. This is a pointer variable which holds the address of node. So whatever the value is written here, if I write this value here, that means now front is pointing to this node. So now our task is achieved. Now front is pointing to this node and this node is pointing to this node, and now this is our linked list. So now we have something like this. So we are able to insert the new node at the beginning. Now let us look at the algorithm, means the logic that we have understood how we can represent in terms of pseudocode, because pseudocode will help you to implement using any programming language. So here we have written a pseudocode. It is very similar to any a program or a function. So here we have insert at the beginning function is there. It takes the value. So we will pass the value which we are looking to store in that node. You will write temp equals to new node. What does it mean? So whenever you write this statement, what is actually happening? It will now first understand what is this temp. Temp is a pointer variable of type node. So this temp will store the address of any node type. So what is happening? You are actually, when you write this statement, you declare one node, this thing you have declared, which has two places. One is for the data, one is for the link. So this statement will create a space for you in the memory, and it will return the address of this location and give to the temp. So temp is a variable, it's a pointer variable that can store the address of any node. This happens with this statement. Temp info equals to well. So now here I am using two field, info and next. So one thing to keep in mind, I may be using data and link field. So data is actually to store the actual value and link is to store the address. But here in our code we are representing this data as information. So we have the field info. We have already made our class node. Inside the node class we have info, which is of type integer, that actually refers to the value which you are looking to store. And also we have one link field which we are calling as a next. Next is actually a node type pointer which can hold the address of a node kind. So we have these two fields are already declared. Is the link field. in our definition. So this is referring to info and this is referring to next in our code. So temp info. Now, before you start understanding this kind of concept, I am assuming that you are already familiar with the concept of pointers and you know how to refer to the pointers, right? So if you are having a pointers, you are using this indirection operator to refer to the fields. So here we have two fields. So temp, with this pointer, I am referring to this information field. So in the information field, I am going to write the value which I have passed here. So I have stored the value here. So now this contains the value. If head equals to null, initially the head is actually null. So head is a pointer variable that stores the value of the first node. So if this is head equals to null, that means your list is empty. The meaning of this is empty list or no linked list created so far. There is no node existing. So what is happening? If there is no node happening and you want to insert this node as a first node, that means this becomes your first node. Okay, so what you will do, you will say head equals to temp. Temp is storing the address of this node, and when you say head equals to temp, that means head is now going to store this address. And temp next equals to null. Now temp next means this field. Temp info is this field. So when you say temp next equals to null, that means this is going to be your the last node. So just keep in mind, this is now happened. We have a head. In the head we have able to store the address of this node, and here we have stored the value, and here we put null. Null means actually there is no further connection. This is the only node in the linked list, because we are in this condition and it says the list is empty. That means whatever the node you have created, it becomes the first node and the last node also. So you just write in the link field, you write null. Null means there is no address for the further node. Otherwise, if the head is not null, if the head is not null means already the list is existing. So let's say we assume some scenario, we have this kind of scenario, we have two nodes already existing. This is the last node, this is the first node, this contains the address of this node, and we have some values, let's say 1, 2 and 3, and this is head and it points to this node. Now this condition is false now, because already we have linked list existing. Head is not null because head contains the address of the first node. Okay, and we have the scenario, we have a new node whose address is at the temp, and we already kept here well, and this part is not yet decided what to write in this. Else what is required? Temp of next is head. What we are going to do is, in the temp of next field, this is the next field, here we will write the value of head. Head contains the address of the first node. If I write this value here, if I write this value here, that means now this contains the address of this node, and head equals to temp, and I will assign the value of temp, this value I will assign to head. That means head is now pointing to, instead of this, head is now pointing to this node. So now what is the scenario? Head points to this node points to this node, and actually we got scenario like this. This is our node which is containing value, this contains the address of second node, and this contains the address of this node. This is the last node, and now this is head. So this is we have achieved. So logic is actually simple, but you have to be very careful when you deal with pointers, because if you miss any of these statement, or if you write any of them incorrectly, then the entire logic will be, going to break, and you will not get the desired results. Okay, next, inserting at the end. So we have a node and we are interested to insert at the last. Again the same statement, we have a pointer of node kind, it will store the address of any node, new node. So when you write this statement, the meaning of this is, we have created one node, and this node address is given to temp. So temp is actually stored the address of this node. This is the meaning of this line. Temp of info is value. So this is your information field, this is your next field. So in the information field you write the value. What is this value? The value which you have passed, which you want to store. Temp of next is equals to null, because we are very sure that this node is going to be the last node. That means it will not contain the address of any other node. Being the last node, we will write here null. Null means it will not contain the address of any other node, so we will write. So this is already done. Now if head equals to null, if head equals to null means, this means we have a empty list, there is no linked list existing, and this node is going to be the first node. So what we will do, we will use the same logic that we did. Temp of next is equals to null, already it is null, and head equals to temp. What we will do, we have a head which is actually null, don't have any address. Now we will assign the address of this the value of temp. This value will assign to head, so that head is now pointing to this node, and is the only node, this is the first node we have added. So when the list is empty, inserting any node will be treated in the same way. You can say it is inserted at the front or at the last, it is the only node. So it is the same logic works in both the cases. Otherwise, if there is already a list existing, let's say this is our list, let's say 3 nodes are already there, this is the last element, this contains the address of this node, this contains the address of this node, and let's say we have some values 4, 5 and 6, and we have a head, and head points to this node. And now we have a new node which contains val here, and this is going to be last node, so we already put the null here, and the address of this node is with temp. This is the scenario. Now we are in the else part. What is required? So logically, let us understand what is required. You need to start from here, so you need to reach to the here. Unless you reach to the here to this node, you cannot connect this. So first you have to reach from this node to this node, from this node to this node, and once you reaching when you are reaching here, you need to provide this address. Means if you write the value written in temp to here, that means it will connect to this node, and then our task is done. So the very first task is you have to reach to this node. How we can do this? We can do this by making one temporary pointer. So what we will do, we will make one pointer. This is pointer we are creating just to traverse this, this kind of situation. We need to traverse our linked list, so it's a pointer of node kind. We created one pointer actually, which can hold the address of any node. Then current equals to head, so we will be using current. We are calling it cur, you can say. We assign equals to head. That means now current is also holding the first node address. That means at this point of time, head is also holding the first node address, current is also holding the first node address. The purpose of the current is to keep on moving from one node to another. Okay, so while current next is not equals to null, so this is your information field, this is your next field, this is your information field, this is your next field, this is your information field, this is your next field. So until the current next becomes null, it is not equals to null, you keep on doing current equals to current next. Okay, so now look here, this node is current node, and this part is current next. Now this current next is not equals to null, because this holds the address of any other node. Okay, so this condition is true until the current next is not equals to null. What you do? Current equals to current next. Now current next hold the address of this node. So when you say current equals to current next, that means this is the location of current next, which is actually referring to the next node. So if I give this address to current, that means at the very first iteration, this is called as current. Now the moment you write this step, now this becomes current. Okay, I think you understood how we are moving. So At the very first case, this is the current. Now this is the current. Again, we will go back and we will check what is happening. Is current next? Now this is the current next. This becomes current. This is current next. Is this equals to null? No, this is not equals to null. So again we go inside the loop, and what is happening? We assign current next equals to current. Current next is this node. That means now this node becomes current. You go back here and again check. Is current next not equals to null? No, this time current next is null. So this condition get false and you come out of the loop. You come here. Okay, now this time this is the current next equals to temp. What is required? This node is current, this node is current next. In this value, in this place, you write the address of temp. So you write this address here, temp. Now temp, when you write this value here, that means this node is now actually connecting to this node, and your task is done. So just to summarize, we need to move from node to node, reach to the last node, and in the last node address field we need to put the address of this new node so that we can connect it. So this is how we can do the insertion at the end. Next is insertion at the particular position. So we have seen that how to insert at the beginning, we have seen how to insert at the last. Now how to insert at a particular position. So here we will be using the logic similar to the logic that we have used to insert at the last. How? So the objective here is we need to insert a node somewhere between the first and last. So what we are going to do is, here we will be going to take two temporary pointers. One is called as a current, other is called as a previous. Previous refers to the in the other way I will say, the current will always refer to the node on which we have a hold at any point of time. So here we need to, like in the previous case, we have seen that we have to traverse from node to node. So this is actually, let's say, our linked list, something like this, and this is our head which points to the first node. So in the previous case, in the previous algorithm, we have seen we need to move from node to node, and we are calling it, when we are at this node, we are calling this as a current. When we reach to this node, this becomes current, and then this becomes current, and then this becomes current. This already we have seen this logic. Now here we need to track two nodes at a time. What we are doing, we will be keeping two variables. One is current and other is previous. So what is happening? Initially the current and previous are the same thing, but as we move forward, the current will represent to the node on which we are, and previous refer to the node that is the predecessor of that node, the previous node of that. That means when the current is this, then this becomes, means if this is current, then this becomes previous. When this becomes current, then this becomes previous. Then this becomes current, then this becomes previous. So we will make such a logic that every point of time we have a hold on two nodes, the current node and the predecessor node, the previous node. Let's see how this logic will work. Also, we need to understand one situation that is called overflow. Overflow is a condition that occurs when we try to create a node, but there is no sufficient memory available. So we will see two terms. One is called overflow, and other is called underflow. So underflow we will see later. Overflow comes in picture when we called of insertion, and underflow comes in picture when we talk about the deletion. So we are talking about the insertion, so we talk about the overflow. Overflow is a scenario when we don't have sufficient memory, to create a node. So the very first task when you want to insert a node, you need to first create a node. So sometimes we don't have any sufficient memory available in our computer, so we get an error that memory is not available. Though the situation is very rare, a very rare situation, because we normally have memories available. But if you are getting this kind of error, the meaning is we are not having a sufficient memory to create our node. Okay, let's move. Now understand a scenario. Let's say we are interested to insert a node after the third node. This is our linked list given to us. This is a new node we have created. This is a new node, and the address of the new node we have given to this variable node. Okay, in our logic normally we are calling as a temp. So we are creating a new node and we are giving the address of this node to temp. So let's say for this example it is called as a node from pointer variable that holds the address of a new node. We have a linked list. This is the linked list we are having. This is the last node, and our logic is we want to insert this node somewhere after the third node. Means this is first, second, third, and after the third node we want to insert this new node. So we need to reach here first, okay, and then only we can apply this logic. Okay, so what is required? Locate the node preceding the insertion point, since it will have to be modified. So the very first thing is you need to reach to this position. So you need to apply the same logic of the current. So initially the current is this, then current is this, then current is this. So you have to reach to this position, means your current must point to this node. This already we have seen, and then we have to insert a node. So let us see that how we can write the algorithm for this particular scenario. Okay, so make a new node point to the node after the insertion point, that is the node pointed to by the node that current node points to. So what is required? uh, this node is pointing to this node, right? And when this node to be inserted here, that means this node should not point to this node, but this node to be pointed here. Though it seems little tricky, but actually this is very easy. Just I am repeating again. In this scenario, in this present case, this node is actually linked to this node. This node connect to this node. But if you insert this node in between, that means this node should not connect to this node. This node should not connect to this node, but this node should connect to this node. So how this is possible? Now, to reach to this node is having an address for this node, right? If I am calling this as a X and this is Y. So to reach to the Y, this node X is having the address. Now, if I write this address here, that means that this node can now reach here. And this is the first requirement. Whatever address you are having here, you need to pass this address to this node so that this node can connect to this node. This is how we can make a connection. Then make a node pointed to by the current point to the new node. Then we have set a connection that this node is now connecting to this node, but we have also make a connection so that this node can now point to this node, and this is only possible. The address of this node is actually the node means stored here. So whatever the value is here, if I write this value here, that means now this node is able to connect to this node, and already we have given the connection from this node to this node, and we have achieved what we are looking for. Let's see how to write the algorithm for this. So this is the algorithm for inserting at some position. So when you call this function, you need to specify at which position you want to insert. You want to insert after the second node or third node or fourth node. So this refers to the position, POS. This refers at which position you have to do, because accordingly we have to make a loop so that we can reach to that particular position, and then the value which we want to insert in our node, we want to store in our inside the node. Now here we have two temporary pointers we have made of node type to make this kind of traversing. One is called as pre and the other is called as current. Okay, then we have a new node. Already we have discussed that we have created a new node, something like this, and the address of this node is given to temp. So temp stores the address of this node. Temp of data equals to val. This is your data field Now sometimes you call it data field, sometimes you call it info field. Now it all depends what kind of definition you have given, but the meaning of this is data field, this is the address field, link field. We call it next field also, right? So here you write the value. So here we have written val. So in the data field you write val, and current equals to head. So we have two variables, current and previous. Of these are the pointer variables of node type. So we have set that current equals to head. We have given the address to the current. So actually the scenario is something like this. This is your linked list. This is your last node. This connects to this node. This connects to this node. This connects to this node. This is your head, which connects to first node, which actually holds the address of this. So when I say current equals to head, that means now current also points to the first node. That means at this point of time, head also stores the address of first node, current also stores the address of first node. Integer I equals to 1 to a position. So if you are saying, if you want to insert after the second node, so you have to make a loop that will go up to position. Okay, so I equals to 1 up to less than position. Fine. So if you want to say that it has to be inserted at the third position, so that means you have to go to the second, means you have to go here, and then this to be shifted here in third position. Okay. Now this position can be used in many different ways, depend on the logic. You may say it has to be inserted in the third position, or you may say it has to be inserted after that position, means uh, after third position, or to make it as a third position. It all depends. So depending on the logic, you can make it as equals to and less than. So here I am interested to insert this at a third position. So here we have also one pre, which is a pointer which I have assigned as current. That means initially, actually, uh, previous, current, and head all are pointing to the first node. At the very first stage, initially all points to the first node. Then current equals to current next. So what does it mean? First thing is int equals to 1. Let's say position is 2 here. Position is 2. So we have to make a loop this number of times. So I equals to 1, pre equals to curs. We have given the previous equals to current, current equals to current next. So current next is, this is current, this is the next field. Current next means this node. That means after the statement we have this as a previous, this is a previous, and this is a current. Now previous, now this we have to, this is inside the loop, so we will come here only when we finish the loop. So now we will go back and increment I, and we will check that 2 is less than the position. Here we want to insert the node as a second, at a second position. So we will go back. Here our logic is we want to insert at a second position. Second position means we have to insert it here. Okay. Or let us look at one more iteration. We want to insert at the third position. We make it 3, right? So when you go back, already I incremented. So we are checking from I equals to 1, I less than 3. Now value of I is 2. So 2 is less than 3. This is true. We go here. Now pre equals to curs. So now this becomes previous. This node will be previous. And current equals to current next. This becomes current. This becomes current. And then you go back. Now I becomes 3. So 3 is less than 3. No, you are out of the loop. So you are out of the loop. You are here. So at this point of time, this is current and this is previous. Now keep in mind, this is current and this is previous. Previous next equals to temp. Now we want to insert at the third position. So actually we want to insert somewhere in between the two. This is first, second, and we want to insert somewhere here. Okay, we want to insert a node somewhere in between here. Okay, so let us say here, this is the one new node that we want to insert. So previous, next, we assign that value of temp. So this is previous, this is the next field. In this next field, if I write this, this is temp. Temp is your new node. If I write the address of this node which is stored in temp, if I write the temp here, that means now this node is going to connect to this node. Now this node is not connecting to this node. Okay, disconnect this node because I have written the value of temp in this field, and this is the field which actually makes the connection. So now this connect to this. So at this point of time, this is the first node, second node, and third node, and then we don't have any means status. We cannot move further. So to make it complete, we go to the second statement. Temp next equals to current. So current we will write in the temp next. Now current is actually address of this third node. So if I write this in the next field, this is the next field, right? If I write this value here, that means now this node is going to connect this node. Again I repeat, current is actually referring to the third node. Okay, after the insertion, this node is going to become the fourth node because I am going to insert this in between. So I am going to write this value inside the next. So when you write the next, what will happen? This is going to connect this node. So what actually is happening now? So if I make it a fair diagram, this is the first node, this is actually your previous node, and now you have inserted this new node here, which is a new node. So now previous is pointing to this, and this is your this node. This is now pointing to this node and your last node. So this is how we have achieved the insertion. We have inserted this at the third position. So third position we have inserted is first, second, and third we have inserted. So to achieve this, we need to capture the two nodes, the node which is actually after the desired position node and the previous. So this we have captured with the logic of current and previous, and then we did some logic and we have achieved what we are looking for. The next is with a specific value. You may say that you want to insert a node after a specific value. What does it mean? It means we have this kind of status. This is a head, point to the first node. This is connection. This is connection. This is, let's say, 12. This is 9. This is 26. These are the values of the node. So I am saying I have a new node, and I want to insert this node after value 9. So that means I need to search that value 9 and then I am going to insert. So that means in this case I will start from here. Is this 9? No. I will move it. Is this 9? Yes. Then insert it here. This is the situation. So we need to write the specific value at which value you want to insert and the data which you want to keep it here. Let's say the value is you want to keep here 20. So let us understand. Again, we will because we are inserting here, so we need to keep track of certain pointers. Actually here even if we don't use this pre, we can get our tasks done once we reach to this node. Once we reach to this node, we can manage this node insertion. Let's see how. This is your current. We make one temporary pointer current. Then already we discussed this is a new node whose address is inside the temp. The temp refers to this. Temp data is data. Whatever the data you are inserting, that should be kept. Let's say 20 here. Current equals to head. So here I am not using the previous logic. It's already, we can also do without previous. So I am just removing this. So current is also pointing here. Now until the current data is not the special value. So this is current data is 12. We are looking for a 9. So until this value is not 9, you keep on doing with the while loop. What we are doing, current equals to current next. So current next is this node. So this becomes next. So after the statement, this becomes current. Again, you go back. Current data is not equal to special value, but now current data is equal to special value. The condition get false. You come out of the loop. You come here. Means you are here. Current is pointing to this node. Temp of next equals to current. So what is required? You want to insert this node here at this position, this new node. So temp next, what you will do? Temp next is this. What you will do? You will write here temp next equals to current next. This is actually not complete. You will write current next. Current next is this area. This area is actually the area address of the next node. So if you write this value here, that means this node now connects to this node. Okay, and current next equals to temp, and current next at this area. Now this value we have written here, and now here we will write the value of temp. If we write it here, that means now this node is going to connect this node. So now we have a connection, this node, this node, this node, and this node, and we have achieved what we are looking for. But one thing to keep in mind, the order of this statements makes a difference. If you write current next equals to temp first, means if you write this address, if you write this statement first and this statement second, then your program will not work. Because if you write this statement, then what you are saying, you are going to overwrite this value with this value, means you have lost the address of this node. Once you have write this statement, the previous value is going to overwritten. And then if you write this statement, temp of next equals to current of next, means when you write this address here, it will simply reflect to the same address, means you are making a self kind loop kind of thing. So you have to be very careful when you write this kind of statements. First write this statement, then write this statement, and now we have achieved. So in this lecture we have discussed how to insert a node at the front, at the beginning, at the last, and also in the between, based on some position or based on some value. So that's all for this lecture. In the next lecture we will see that how to apply the delete operations in the linked list. Thank you very much.